In this section, we will be covering how to solve quadratic equations using three different methods. The first method is factoring. That's one of the most important topics probably in algebra, and that is why you reviewed it last year in PST. The second method will be completing the square, which is probably a method from algebra that you have forgotten and plays a key part of this year in terms of converting to vertex form as well as converting conic sections in the third quarter. And lastly, the method which you probably remember very well, the quadratic formula. So let's begin this review. Factoring. The first most important thing with factoring is that this must equal 0. You cannot factor something unless it is equal to 0. Therefore, we can use the diamond approach for our trinomial from last year. What multiplies -5 adds -4? -5 and plus 1. Therefore, the solutions here are x equals 5 and -1. On the problem over on the right, it's a little more difficult. This is not equal to 0. Therefore, our only option is to multiply everything out and then try to factor it. 3x times x is 3x squared plus 12x minus 2x minus 8, and I'm going to add the 11 over, so it's equal to 0. Now I can add and group all the like terms, so we have 3x squared plus 10x plus 3 equals 0. So I'm going to factor this trinomial. For me, I usually say what multiplies to 9 and adds to 10, and that would be 9 and 1. Therefore, the factors of this trinomial are 3x plus 1 and x plus 3. You will not see me reviewing factoring this year. By now, at this stage, you must know how to factor by whatever method you may have learned over the years or whatever way suits you. So x equals -1/3 or -3 are the two answers. Now I'd like to review completing a square, which, like I said, is probably one of the more important methods of this year because it's something which you've completely forgotten. Completing a square, the whole goal of completing a square is to get something like this. X minus 1 squared equals to 9. And therefore we could square root both sides and solve it from there. So that's kind of our goal. So if I look at this first one, the first thing I'm going to do is to x squared minus 4x. Now I'm going to put a blank in here because I'm not sure what that number is. And now I'm going to set that equal to -1 plus blank. So this is the one method of solving quadratics where you move it over to the other side, the number to the other side, and do not set it equal to 0. Now I want to complete the square here. So I want a number here that's going to factor into a square like that. So I take the middle term and divide it by 2 to get -2. And then I square it. That gives us 4. If I add that to one side, I must add it to the other, and that's the whole point of the blank. Though the blank may seem trivial at this stage, when we get to later on this year in the chapters in the third quarter, we'll be completing a square twice in one problem, and those blanks become very important because it reminds you to add it to both sides or do whatever you need to do to balance the equation. So if I add 4 here, I must add 4 here. So now, I can now factor this into x minus 2 times x minus 2. Notice these numbers match. That should always happen no matter how filthy a problem becomes. So we get x minus 2 squared is equal to 3. We can then square root. Remember, when we square root a square, we end up with a plus or minus. And then we can add the 2 over. To get our answer. Now let's do the fourth example, and the reason why I'm doing 2 examples is because of this coefficient. This coefficient, you cannot complete the square with a coefficient in front. We must divide that out. So right away you must take this and divide it by 2. Now we can complete the square. So let's put in our blanks. And add the 7/2 to the other side. We can take -6 divided by 2 to get -3. Square it, you get 9 in the first blank, 9 in the second blank. We can now factor this to x minus 3 squared. Again, if you do it correctly, that number should match. That is equal to 25/2. We can now square root. Again, when we square root, we get a plus or minus 5 over the root of 2. We cannot keep radicals in the denominator. So we have x equals 3 plus or minus 5 the root of 2 over 2. From PST, you learned that we must multiply this by itself in order to get it out of the denominator. And that's our answer. It is not uncommon to get complex numbers here. You may see, for example, if you go back to number 3, maybe there would be a -3 in there. If that was negative, it would be plus or minus I the root of 3, and so forth. The last method I would like to review for solving quadratics is the quadratic formula. First and foremost, we can prove the quadratic formula by completing the square, something which I can do with you in the first couple of days of next year, just to show you that. That's one reason why in algebra you learned completing the square before quadratic formula, but then you never use it again because the quadratic formula works for all quadratic equations, no matter how simple or complex that they are. It will always give you the two solutions. First and foremost, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. That is something you must memorize and must be able to use at any given moment this year. So again, like I said, this solves any quadratic. So whenever you're stuck, if you can't factor it, if you can't just simply square root something, you can always count on the quadratic formula working. First step again is always make sure it's equal to 0. So 2x squared minus 4x plus 7 equals 0. So -b would be 4 plus or minus the square root of b squared. -4 squared is 16 minus 4 times 2 times 7 all over 4. 4 times 2 times 7, that's 8 times 7, which is 56. So you get 4 plus or minus the square root of 56 over 4. Just to kind of review this, the inside of this radical is what we call the discriminant. The discriminant again is b squared minus 4ac. And the only reason why it's important is because it tells us what kind of roots we have. If this is bigger than 0, we're going to have 2 real roots. If it's less than 0 or negative, we're going to have 2 imaginary roots. And if it's equal to 0, we're going to have 1 double root. And we'll talk about double roots next year, as well as triple roots and so forth. Now we must simplify radicals. The square root of 56 is 8 times 7. So that's going to be, if we simplify it, I'll do it down here just to review from last year. It's 8 times 7, and this is 4 times 2. The square root of 4 is 2, which leaves us with 14 under the radical. We can simplify this because 2 goes into this number, and this number. So this becomes 2 plus or minus the root of 14 over 2. In reality, all we did there was actually factor. We took out a 2 and got 2 plus or minus 2 to the root of 14 up on top, and canceled that 2 with the 4 in the denominator. I bring that up because it's not that we actually can just divide anything we want, but in reality we are factoring and then canceling out that 2 at the bottom. That wraps up the review of quadratic equations. We will do more of this next year with much more complicated radicals. But for now, this will cover what you've seen before in your algebra courses. You should now be able to go back and complete section 1-6, solving quadratics in the summer assignment.